is Daniel. I had the pleasure to work very closely with the core data team for a project I did while at Apple. And I want to share with you some of the things I've learned and some of the things to do and not to do. So it's we'll rush through this and see how far we get. So quickly, what is core data? Well, we're going to get a quick recap of the core data stack, what goes where. Then I'll go into some more detail about managed object context. What are those? How should you use them? Then I'll talk about various things related to performance, and we might even get a few minutes to talk about the famous incremental store. So what is core data? Well, core data has been around for a long time. It was originally shipped in 2005 as part of OS 10.4. It's like a long time before anybody believed Apple was even going to build a phone. On iOS, it showed up in iOS 3. It took quite a while to get there. The interesting thing, which is maybe not so interesting to iOS development, but it is a framework that sits below the UI. There is no dependency on UIKit. So if you should ever travel off and do something on the Mac, you can actually develop tools that run in some daemon and still use core data. It is a fairly low-level framework in that respect. Well, core data is a persistency technology, which is this kind of very fluffy term. The main part about core data is its very powerful object graph management. Another cool term, and we'll get to that in a bit. It's not an SQL wrapper. If the thing where people kind of fall off a cliff most often is they're like, oh, I want to do some SQL, and core data sounds cool, so let me start using core data. And that is not what core data is. It's not going to help you do your SQL stuff. You can try to do that, but you'll fail just like all the thousands of other people. And if you come from there are these ORMs, which kind of wrap some SQL to some objects, and that's also not really what core data is. So forget everything you know about ORMs in SQL, and let's take a look at the core data stack. But what's better than core data stack is Doner kebab. And it's the national dish of Berlin, so to speak. And if you take two of them and put one upside down, it looks like this. And that is your core data stack. So obviously there's a bit more to it. Oh, I'm behind. In the middle of this Doner thing is the PSC, which is the persistent store coordinator. And it's also called the central scrutinizer because everything from the top goes through this thing to the bottom and through it. And that's your persistent store coordinator, which does all the coordination. On the top part of this thing is where all the fun happens. That's where you have your contexts, and the little red dots inside these contexts are your objects. Core data scaled from very simple to very complex scenarios, and in complex scenarios you can have as many contexts as you want, though in most situations you will only have one. Each context has its own objects. On the bottom part is the kind of boring part that you shouldn't do too much with. The bottom part is where you have your actual store objects, and then at some point things actually get persisted to disk. The bottom part, where the persistence happens, is what SQL wrappers do. It's what ORM tools mostly address. But the real power of core data is in the top part of this graph, and that's what we're mostly going to talk about. And if you've worked with core data before, it's really important to take a step back and let go of some of the SQL stuff and think more in terms of objects that have relations to each other. So in this top part, there are these managed objects, which are the red dots, and there are the contexts. Usually we'll only have one context, but in a context you will have multiple objects, and that is where all the fun in core data happens. So let's get into some detail and talk about models. We could easily talk about hours for how to do models. I'll run through it in 10 seconds. But a model really describes what kind of data you want to persist, what kind of data you want to store. There are long books about how to write database models, and if you studied something in university, that probably was a very fun class to take, but most of this is not very good. You can't have a slideshow without the burning effect, so I have to put it in somewhere. Lots of classes talk about something called third normal form, where you kind of normalize your data. It is very bad practice in general. You shouldn't do that. Instead, what you should do is create the model based on how your UI looks. Look at your UI, see what you have there, create your data model based on that. That's what I just said. So let's take an example. This amazing app. This is an example of an app. So what you have in this kind of app is a classical table view, and you display some stuff in it. So look at the individual thing that you want to display. What data is it? So this will give you a very good model of how you should create your data. Don't go back and try to be too analytic about, oh, I could optimize these things, but try to create a mapping that is fairly close to how your UI displays things. Don't go off and create sub-objects for things because you could. If you have one view that displays a certain amount of data, have one object for that, put the data in there. And here's another example. You have some ingredients. It has two properties. Make that your model in the thing. Yeah, basically it's very simple. So with that, you want to put some data into your model. And that is where managed objects come about. So each of these model things, which are called entities in core data, kind of in a data world correspond to what a class is. And now that you're in the Objective-C runtime that we just heard about, you have a class that's called NSManaged object. And it has a relationship to this model that you created. The NSManaged object would represent one of the ingredient objects that we had, or one of the cocktails. These objects hold onto your data, and the important thing to note here is that it is just a normal object. Like back in the days of retain and release, you would retain and release these things just like any other object. And there is some stuff happening in the background so that core data puts the values into the object and saves them, but it's not too magic in any other way. It is just an object. The important thing is when you create a subclass of NSManaged object to hold onto your data, use that class in your application logic. If you create an app with authors and books, which I'll give some examples about, you put the logic for those objects into that class. You use that authors class that you created. You send that authors class to your view controller and pass it around in your app. One of the common mistakes I've seen, and which is a really, really bad way to use core data, is that people pull out these managed objects from disk somehow, and then they read out the data and store that in their UI, and then throw away the class. That is not what you should do. Use these objects as citizens in your app and pass them around. You can have your managed object class implement delegate methods. You could have your own protocol. So you have a view controller that can display a certain thing, and you can pass in different kinds of NSManaged objects. all the standard things you can do in Objective-C, use those with these managed objects. And so here's one example of how to actually implement such a subclass, because if you look on Stack Overflow, I think yesterday we saw a pretty good thing about examples that are not very good, and Stack Overflow has a lot about core data that are not very helpful. So if you create a model like this in Xcode, we created a book entity that has some attributes like page count, title, publication date, and it has a relationship to authors. How would we, let me see, we have a second one that's called author, first name, last name, and has a relationship back to the books of that author. So how would we implement that? So of course we subclass from NS-managed object to create our book class, and then again, this is just very standard way of implementing your or not writing the interface for your class. You have the attributes, which are just properties, and back in the day you would write everything as an object, but nowadays, like the page count, you can just make that an int 16, and you don't need to wrap everything in NS numbers and unwrap it. Your properties can just be normal numbers. And there's even a trick, if you search for Stack Overflow, it's hidden somewhere far away, but where you can do the same with enums and store enums directly in core data without having to wrap them in NS numbers. Then there are the relationships. This is also something where a lot of people go through a lot of trouble and make things a lot more complicated than it needs to be. The thing that I would recommend is that you write your authors relationship just as a normal, in this case, ordered set of authors, and it's your normal property. You can very easily create a read-only property that gives you a mutable, in this case, ordered set or immutable set. You can then put stuff into that collection and remove it, and when you save the context, those changes will be updated. Instead of having to create 50 methods on the class for adding and removing book, this will give you an off-the-shelf mutable ordered set, or mutable set if it's not ordered, that you can manipulate directly. And here's the same thing for the author class. The thing to point out here is that I did some very not too clever or not too advanced stuff. You can implement directly in your class methods that use some of the others and return that. So these utility functions, like here, I compute a name, that's the first name plus the last name, define that directly on your class and use that there. And the same thing for the relationships. There is, again, I have these mutable books, which gives me this mutable set. So how would we implement this? Well, let's look at the author class. These are the things that core data actually stores. We are not going to implement them because core data does that for us. So the only thing we're going to do is write dynamic first name, last name books. And what dynamic does, all it does is tell the compiler to shut up. It does not generate any code. Otherwise, the compiler will tell us, hey, you said there's a first name, I can't find it anywhere. And then we add our own stuff. And the only stuff for this that we need to add is, again, this very not too advanced thing of creating the name, just first name plus last name. And then this is how you would create these mutable sets. Have Objective-C return a mutable set that works with core data. All you do is return a mutable set value for key. Core data has already done all the logic for us to know what books is. It is this relationship from the author to books, and the mutable set value for key works with core data to give you a set that you can change, and those changes will be reflected in core data. And I would really recommend you to use this pattern because it makes the code a lot easier to read and understand. And that's what I just said. So the next thing that is another very tricky area about core data is faults. An NS-managed object holds onto your data, but it can actually be an object without data. It can be a so-called fault. an object can be around with any data in it, which sounds like why would you want that? But the very same object can just be a promise of data to be loaded at a later time. And the reason for that is that you don't want to pull in all the data necessarily. So core data allows you and automatically does some trades of how much data it pulls in. And if you look at a graph of objects, so let's say this is our graph of objects that we have on disks. If we pull in a book, we don't necessarily want to pull in all the authors of that book immediately, because if we cascaded through all the relationships, we would just pull in all data from disk. So core data does this. Once you ask for the data, it'll pull in the books. You ask that book, you get the other authors of that book, and so forth. So core data allows you to lazily populate what you have in memory. And it is being able to manage that can be more advanced. But if you work with large data sets, this is the only way of making sure your app doesn't crash because you run out of memory. I'll touch upon that a bit more later. And, sorry. Some other recommendations for managed objects. The thing that also confuses people at the first time is like, how do you create these things? And I think these slides will be posted somewhere, but following this pattern makes it very easy for you to create new instances, because you cannot use alloc init directly because the object has to be tied to something. Using this pattern makes it very easy in your code to create them instead of having to write huge constructs every time you need a new one of these. Sorry. Another thing, side note on it, entities in your models are a bit like classes in your code. But the important thing, and one thing where you can do a very powerful thing, is to realize that your class graph does not have to match your entity graph at all. You can have a totally flat class hierarchy and have a nested entity hierarchy. You can have a totally flat entity hierarchy and have a nested class hierarchy. That may sound very confusing, but the thing to be aware of if you think about how databases work is that when you have sub-entities, all of those have to, in the database, go into the same table, and that might kill your performance. So usually it's not a good reason to, it's not a good thing to do sub-entities. It's good, unless you really know what you're doing, is to have a flat entity, have no entity hierarchy. But that doesn't, but you can still do subclassing in your classes, in your subclasses of n as object. Have one shared base class for your managed objects. It's a bit of an advanced topic, but it makes working with core data a lot easier. So the context is where your objects live. It's the home of your objects. And the important thing to understand here is that even though your objects hold onto your data, core data still needs to know about these objects. It's a very different way from these more low-level ORM tools, is that core data, the stack needs to know which objects are around. It needs to know which objects are updated, which ones have been inserted, and so on and so forth. So the object cannot live on itself. It always lives inside a context. The main role of the context is to keep track of changes. It does a lot of heavy lifting for you, and this is really where the power of core data comes in. If you create a relationship from A to B, core data makes sure that there is also a relationship back from B to A. Then there is something like delete propagation, which may sound super trivial, but if you implement that yourself in plain SQL, it becomes obvious that whenever you delete an instance of B, you have to go through all of your database and figure out anywhere you reference to that, you need to update that. And that is the heavy lifting that core data does for you. It'll automatically propagate these deletes. Core data also does undo redo tracking for you. You can query the context, which objects are around and which ones have changes, and it holds references to all your objects. So you can do more advanced stuff where you use these features. The context is also the first point of contact to doing anything with core data, because the context is what you will use to fetch your objects from disk originally. The context is what you will have to use to insert stuff, because it needs to live in the context, and it's also used for deleting and saving. You can have, as I mentioned, multiple contexts. It is a more advanced use case, but you can do some really cool stuff. Each context has its own edits. If you change things in one context, it's not going to be reflected in another context. You have to do that manually, and it's again, core data gives you the flexibility of whether you care. Does the other context care about these changes? The thing here is that objects, as I said, live in a context, so the object is unique to its context. But in the other context, you need a different object for that thing. You cannot pass objects between contexts. And many things, I mean, it's the thing like you have a problem and you solve it by using threading, and now you have two problems. You can use threading in core data, and the thing, again, you need basically a context per thread, or nowadays a context per queue. And so if you want to do background work, again, you need to work with multiple contexts. There are some things to be aware of, but it allows you to do powerful things. The other thing is about the context. You saving in the context persists your changes. A save is transactional. It will either save all your changes in the context or nothing, which is another important thing to be aware of. It allows you to do some things, but there's also some things that don't work because of that. It famously does automatic conflict resolution, which does not mean that core data is insanely brilliant about what it does with conflict resolution, but it will automatically either resolve the conflicts or fail. Again, there are some advanced topics there, but you can basically implement your own merge policy or use some of the pre-built ones where core data automatically throws your changes away or keeps them, throws the other changes away. But the important thing to note is it's transactional. If you, in your object graph, change 10 things, either all of those 10 changes go to disk or none of them. So obviously you want to get some of the data off disk, and this is often where performance comes into play. What you will do, you create an fetch request and have the context executed, because the context will own the objects. And this is where you need to make I/O trade-offs. And it's, as I mentioned before, it's the thing of how much data do you want to pull in. And whenever you have performance problems with core data, this is probably the reason, that you're either pulling too little data in, so you keep pulling tiny pieces of data in, or you just pull in too much data at once and you don't need all of that. The fetch requests, some key things. Fetch requests can sort stuff for you. Don't go through and sort stuff after you fetched it. Databases have been optimized for 40 or 50 years to be good at sorting. When you fetch stuff, most of this is in the fetch results controller, is pretty automatic, but if you fetch the data yourself, core data supports something that is batching. Imagine that you want to run through a set of 1 million books. You don't want to pull 1 million books into memory, and core data can do batching for you, which means it'll, as you iterate through the array, gets rid of old stuff that you're no longer holding on to and pulls in incremental sets of new data. It's a very powerful technique. Fetch requests can do counting for you. If you want to know how many books do I have in my database, don't go through the trouble of pulling all those books into memory. You can have core data, just return you a number. It's way faster. Fetch limits is another thing on fetch requests. Sometimes you just want to know, are there any books? So you can just tell the database, give me all books, set the fetch limit to 1, which means you'll either get 0 or 1 books. Or you might have some UI where you just want to show some book, or you just want 10 books. Again, you do less I/O work. It can help performance a lot. There's some advanced stuff you can do with dictionary result type, very advanced SQL stuff that you can do with it, but basically instead of returning objects, you get these dictionaries, which are, as we saw yesterday, too. There are some horrible things about it, but you can do really cool stuff. You can do aggregation, so you can only get unique values from your database. You can have the database, I mean, it's even below the core data level, but you can have the database do math for you. If you want to sum up the number of pages of all the books of an author, instead of pulling those objects in, doing the math in memory, you can actually have the database do the work. Again, you save a lot on I/O, and it helps performance. You can get numbers of relationships and stuff like that, again, without having to pull in the data. The important thing here to get all this magic to work with fetch requests are predicates. Predicates allow you to target your search. And again, it's all about performance, doing less I/O, only pulling in the stuff you need. There is often these code bases where people pull in 10,000 objects and then search through those 10,000 objects to find the 2 that they're interested in. Write a good predicate so you only pull in those 2 objects. That makes a huge difference in performance. So predicates, a quick run through. You can do something like that. Well, I want the books whose author's last name is Eggert. Simple stuff like that, where you go through relationships. You can use predicates against too many relationships. So you want the authors, you're fetching the authors where they have any book whose title is core data. Again, you go through a relationship. And the very advanced and very powerful thing you can do with these queries are predicates are subqueries. It's an advanced topic, but if you go through too many relationship and you want to check stuff on that relationship, you cannot just say you cannot just check that the first name is something and then also that the last name is something, because the first name might match on one author and the last name on another author. Subqueries allow you to very powerful things. And we'll skip through some of this. So this is another thing. If you want to match for an actual object in a relationship, you can pass objects, like your book objects, directly into predicates. It helps performance a lot. And we'll skip through here. There is a document in the Xcode documentation that is called Core Data Snippets. Check that out. There are a lot of very good examples about predicates, how to write them and not write them. And with that, we're on to performance. The top 3 reasons why core data is slow, and if you look on the web, everybody's complaining about it being slow. It's either slow because you're loading too much data, or it's slow because you're not loading enough data, so you constantly have to go back to disk, or your queries are very inefficient. But these are not problems with core data. It's just a problem of anything you would do with database, and managing those is what will make your project fly. Loading everything is bad. Use batching or use aggregation to only load the stuff that you need and not too much at one time. Use sorting and filtering in the database. Don't do it in memory. This is if you load too much data. If you're not loading enough, you have to remember, even nowadays on your iPhone where the file system is flash-based, disk I/O is insanely slow. you can do millions of calculations in the time it takes for the operating system to go to disk and load something up. And so you want to make sure if you go to disk that you load the data you need and that you don't constantly have to go back. The classical thing is that if you scroll through a table view, if for each cell that you display you have to go to disk and fetch some data, your scrolling performance is going to be horrible. So make sure you pull in the data you need. Fetch requests can do, time's up. Fetch requests can do relationship prefetching, so you can actually fetch other stuff. This is the most common thing in scrolling through table views. The last thing is inefficient queries. Databases and general computers are very bad at performing strings, so there are a lot of logic you can do, or you don't do string comparisons. Unicode string comparison is insanely complicated. It's thousands of lines of code, and you don't want to do Unicode string comparison. There is a predicates guide, again, on the web, in the Xcode documentation. Last thing I want to show is this launch argument. If you put it to, you can actually see what the database is doing. You'll get a dump like this, and it'll dump some output every time core data is doing something, which allows you to kind of see what is the database doing. And yeah, I wanted to say something about Inna's incremental store. I can sum it down to don't use it. And with that, thank you for listening. No time, no. Yeah, I just have somebody telling me that there is time for questions. Okay, we do.
So I have one question regarding importing mass amounts of data. So you had this example of these cocktails, for example, and then when I want to do an app that has initial data in core data, like 1,000 cocktails, what is the best way to do this, to deliver mass amount of data with the app in the App Store, for example?
So the question is, how do you import lots of data, or how do you ship an app that has a lot of data in it? So there are two different things. Like if you ship an app with thousands of something, I would just add compile time, generate that database, and ship it with the app. There are some technicalities about that, but basically the core data database is just an SQLite database. There is no, like if you create it on the Mac, it'll work on the iPhone and the other way around. So if it's, I would just create it and push it into your app, find it in the bundle, open it, and those kind of things. Sometimes you need to import lots of data, like you're pulling stuff over the network, you push it into the database. And the thing, again, here is that if you add stuff to your context, it is in memory because it hasn't been saved yet. So if you're importing thousands of things into the database, make sure to use batching, insert 50 things, 100 things, save, get rid of those, do the next 10 or 50 depending on, I mean, yeah, performance monitor what is the right number, but do batching. If you insert 1,000 things into the context without saving, you'll run out of memory.
How does core data handle changes of the data model?
It's, it handles it. You can, if you change your model, if there are simple things, core data can migrate those models. If it opens a database that was created with an old model and the new model is a trivial change, core data can do the migration itself. It obviously at runtime needs both the old and the new model to kind of figure out what has changed. If you make more complex changes, you can write code yourself that does the migration when the parts where things are trickier, but there are obviously some things that can't be done. Like if you go from a model where you have a first and a last name, and then in a new model you only want to have a name, you would have to do that migration yourself, but it's totally possible. I don't know.
Here, where the microphone is. I have a question about importing as well. I have to import a few records, about, I don't know, 500 or 1,000. and I cannot ship it with the app because it's live data coming from a server. So I'm always, obviously you can do it in the background. I don't think you spoke a little bit about working on a background thread with core data. From my experience, it's asking for trouble. Then again, you cannot work on the main thread because it's asking for trouble for the user. You just spoke about saving, but saving is also expensive. So what's kind of the best technique to, basically I need to import a lot of data coming from a JSON, and it's very expensive. First of all, the JSON parsing is expensive, and then core data importing is expensive.
There's nothing wrong with doing stuff on the background, and importing is the classical case. It's like the user doesn't really want to look at your screen with just a spinner for a long time, or the app being totally unresponsive.
The problem is context, or and it's managed context in the background.
So you would create a background context. The thing, I don't know when libdispatch came out, but there's this thing about queues, and queues make threading a lot easier because you don't think about threads, you think about queues, and core data supports that model. So what you would do if you want to do core data work in the background is you create another context that is connected to the same persistent store coordinator. You create that context, I forget what the API is called, but there are basically 3 different
yeah, I know what you mean, yeah.
Queue modes or thread modes, I forget what it's called. Anyway, there's a legacy one, which basically, okay, you just have to handle the threading yourself. And then there are 2 modes where the context has a queue. One of them is where the context has the main queue. So you would create one context like that for all your UI work. Because if you use that context queue, you use the main queue, which is the queue that the UI uses. If you create a background context, you would create one where the context has its own queue, and then whenever you touch the context or any object that is owned by that context, you have to dispatch onto that queue. So the context has a method that is called perform block. Whenever you do work on the context or the objects, you need to use that method. The important thing to know is that managed objects are very dynamic. So even when you read from an object, that has to be done on that queue, because reading the name from an object, that name might not be there. So data has to do work and go to disk and fetch that name from disk. So even reading has to be thread safe. But it's totally possible, and you just switch onto a context, and saving is not expensive. Just make sure you chunk it up into good sizes. Don't save for everything you insert, but don't insert 1,000 things and then save. Those were the words. Thank you.